I'm going to apologize in advance for the fact that this is probably going to get a little bit bumpy because I'm going to hold the camera in my hand. And I just want to go over the components of an HPLC system. So what I'm dealing with here is I talked about before where you get the stack of an HPLC system. So this is the stack. You've got a UV visible detector down here. You have the pump here. You have a mixing here. We have and a degasser up here. We got our solvent bottles. So here's where we keep our mobile phases in here. The mobile phases, run down into. You can hear the pump start running, but essentially these mobile phase, these liquids run into this degassing system. In the degassing system, it removes any dissolved gas that's in the liquid. From there, they'll flow out of the degasser and they'll flow into a mixer here. So this is where your HPLC system will automatically mix. Like right now, it's mixing 80% water and 15% acetonitrile. This is 100% acetonitrile. This is 100% water. But then once it goes through the mixing, it'll actually mix those in a 85 to 15% mixture. At that point, this is the actual pump right here. It pumps through the injector. Right here's our injector. If you look at the injector, there's a little sample loop back here that says, if I can get it to focus, 20 microliters. So for doing injections, that's a 20 microliter injection. The way that would work is on the front end, you can see there's a load position and an inject position. You would put the syringe into the load position. You would fill that loop with it, and you can pull it out, and then you would push it to the inject position. What you've put in the sample loop then here would be carried through the system onto the column. This piece right here is actually our tubular column. It's a C18 column. This is where the analytes get separated in their components. They come out, and finally they go into a UV visible detector here at the end. So this is the whole stack of an HPLC system that you typically see. This is the HPLC system that we're using for our the next lab we're doing. In the lab that we're going to be performing, I extract some capsaicins from a jalapeno pepper. These are 3 standards of capsaicin at different concentrations. So what you're going to end up getting for data is you're actually going to see where I injected each standard. Let the system run, created the chromatogram, printed out the chromatogram. You'll see the capsaicin peaks. The retention times will hold constant. We'll use the peak areas to quantify the amount of capsaicin in the standards, create a calibration curve, and then we'll use that calibration curve to quantify how much capsaicin is actually in a jalapeno pepper that we bought from Walmart of all places. So this is a pretty brief overview of an HPLC system. But this is what I'm going to give you right now. Unfortunately, if you've had quantitative analysis, you've got to use this system a little bit. So I just kind of wanted to talk about the individual components a little bit more detail right now. Wanted to look at the injector in a little bit more detail, the actual column and the whole flow system. And then once it goes through the detector, the solvent flows down into a waste bottle here. So that is our whole HPLC stack and what would particularly seen. This is another HPLC system over here. It's the same sort of thing. The only difference with this one is it has an auto sampler. So this one you don't have to do manual injections. This one will actually do automated injections, or it can do manual injections. But you have the same thing here. You have a detector. You have a pump. And a communication thing and the solvent things are here. So these aren't all stacked up like in one great big stack, but we could actually stack this component and this component, and we could make a great big high stack where they're all stacked up on top of each other also running. You can see in this one there's the column that's used for the separation. Injector looks very, very much the same, so on and so forth. So yeah, those are 2 examples of 2 different HPLC systems. They look very similar. The type of application you're using really is just swapping in and out this column here. You've got these quick things that just spin out of the end. You take this end off, you take the bottom end off, you cap the column, you put a different type of column. This is a C18 column. Maybe you want to put a C8 column on, maybe you want to put a normal phase column on, a cation exchange column. Whatever your application is, though, you would swap out the column, maybe swap out your mobile phase compositions, and you just create new method or application, and but running the rest of the HPLC would be very much the same. That's it.